Okay, for the last section, I want to show a system called SceneChanger. It's available in our forum. If you just search for SceneChanger like this, you'll get bare-bones scene change show system. Jarrett designed this last year, and the idea is, I'll just open it up first. I have a few different ones here in the project folder. We'll start with the base one, which is before any modification. Excuse me. And it's a show building component that can switch between scenes, and it's designed, optimized so that scenes that are not in use will not cook. So you can add any number of scenes to it, and they will not be cooking every frame. It allows, excuse me, it also allows multiple artists to work easily together because it's a very modular system where these scenes are in template components. So you can have people building their own networks and whatever, as long as they build inside this component that just plugs in. I'm choking on my snacks, sorry. It also uses parent shortcuts, which keep the system modular and help simplify the setup, and I'll show what parent shortcuts are. And it also uses Python extensions to allow complete show control through scripts. So if you have another UI system or another piece of software or hardware like a Grandma or Ableton Live or anything else that you want to fire controls, you can just script that with Python extensions here. So let's look at the very top is, go to the top. It's the same as this one over here, but example show is the name of this component. And I have some show settings. The resolution is set here to 1920 by 1080. But more importantly, on the common page is a parent shortcut, and it is set to show. So what this means is anywhere inside this component, you can use this shortcut to get up to these parameters. So we'll use it in every case we want to get this resolution. We can just use the parent shortcut. And I'll show you how the parent shortcuts work in this little diagram. This is our top level. So this would be example show. And this is where we set our parent shortcut. In this case, I said, oh, well, let's call it TDSW. All right. And this component has a width parameter, me.par.w, that we want to get many times down here when we're building. Maybe we always want to know the width of the top parent. Now, in the second level down, if you were to use a regular script or not use parent shortcuts, you'd go parent bracket bracket dot par, and it would be one parent up, grab the par w. Or you could do op dot dot, which means go up a level and get the parent w, or the parameter w. To use the parent shortcut, you can type parent dot without the parentheses, the parent dot TDSW, and that will go up the network and find where the shortcut lives. And it lives here, and then it'll find par w. So the nice thing about that is down another level, you'll see that you can use the same expression. You don't have to worry about how many levels deep you are, like these other two expressions. Or down in level 3, you can use the same expression. It will keep looking up the hierarchy until it finds that parent shortcut. And once it finds it, then it gives you that location. So the reason that's important is, let's go back to TouchDesigner. If I'm building inside the show, and I'm building really deep inside show in here, and I might want the resolution, excuse me, my voice is going. I want the resolution to be set based on, this is a bad example, I'll go into the scenes. And I want this resolution to be set based on, I can say parent scene and go up until, it doesn't matter how deep it is. I could also go like this and say, put it in another component and it still works. I don't have to change it because it just keeps searching up the hierarchy until it finds that parent shortcut. So they're very important to be used. And if you do something like, if I go up a level here and I grab this, I say copy this parameter, and I want to make a new noise top, and I want to use that resolution, and I say paste reference, TouchDesigner is even set up to automatically use parent shortcuts. It is the new way of working in TouchDesigner. If you're building systems, you should be using parent shortcuts because it makes everything modular and easy to plug in. So if you haven't used them before, check them out, and you'll see them all over this project, basically to keep things easy to move around. If I wanted to take this noise and cut it, put it in here, it still works. I don't have to change the path. I don't have to say dot, 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 slash, or whatever. Okay. So let me undo this. Okay. Now we'll go back to here. So inside the show component, this is actually the engine that handles the blending of all the scenes. And you don't really need to go in there until you want to modify it, but the idea is that it takes control of blending and fading and loading. So if I was to, over here on this scene, I have these little 4 buttons for the 4 scenes I have, and if I just click one, you can see it changes, fades to the next scene, and it fades to the next scene. All right, nothing too fancy, but okay. If we go inside, we'll take a look here just quickly. Sorry. On the settings here, it's already using the resolution from above using the parent shortcut. You have to specify a scenes component. So which component should I go and look for all the scenes in? And this is, in this case, called SceneLib. So right beside it, you'll see SceneLib. And inside SceneLib are these 4 scenes that I created. Okay. Now here, without using these buttons here, I was just jumping ahead there a little bit. Here is where you can set your scene that you want to jump to. So let's say I want to jump to scene 3. This will queue the scene. It doesn't jump yet because you might want to set it up and get ready. And then when you want to go to that scene, you click fire. And was I already on scene 3? Okay, scene 1. There we go. And it goes on to that. Displays what scene you're on here. So we can go to scene 2. Okay. The fade time here is simply that. It's just a general fade time between scenes. And the other thing down here just tells you what scene you're on. And then the view scene index will bring up a little table of the scenes that you have in which order they are. So my black scene here is scene 0. My scene 3 is scene 3. All right. Okay, next would be the top is the final output. So I'm going to go in and show the extensions in here just to show where they live. Extensions are set up on the extensions page. So you'll see here on the show, it has inside, there is a DAT called show.ext, and that's where the extension is held. And if you middle mouse click on it, you can see that there is a class show.ext and the different functions that you can call. So for example, the scene change function will take a scene index or a name, and it'll take a fade time, and then it'll act on it. So if we just go over here a little bit, if I say op show scene change 0, it's going to fire this function here, which is 0 scene index, and let's just see what happens. We'll just run that script, and it fires it. All right. Instead of using 0, if you wanted to use the name, you can also do that. Here, in this example, it changes to scene 1, and it includes a fade time of 5, so it overrides the fade time. So we'll just right-click on that, and we'll run that script, and we get a nice slow fade in to scene 1. Okay. Now, if you want to go in and modify this, you can go inside Show. Now, Show is, there it is here, Show EXT. So if I right-click and say Edit, this is the extension. Let me just make it a little wider. Okay. Here's the scene change that we talked about right here. It basically takes in the scene name or index, make sure that it's there, and then basically calls switch to scene. And switch to scene does the dirty work of actually loading up the next one and firing certain gates on and off. All right. Fire scene is the button that we had. So fire scene will trigger a scene if you have next scene set. And there's a gate activation on and off. These are sort of helper functions, but you can add your own things in here. Like maybe you want to show preload, and you want to be able to call opshow.preload and preload all your assets. This would be a place you can put that and then access it from the outside. All right. Now in here, I'll just briefly show what's going on. It's very simple, actually. This opfind component, dat, is looking inside the scene library. Notice it's using parent.show par scene comp, so it's finding out the scene, where the scenes are held. And it's just giving you a list of all the scenes and grabbing them. And then based on that, it's using a replicator to replicate this scene gate. And the scene gate, this is there's 4 of them you'll see because we have 4 scenes. The scene gate is what takes care of the mixy part. So it does a little filter and it mixes them based on its trigger, based on the gate. All right. And it's just doing a constant to, it's basically doing a crossfade. Crossfade, yeah. Okay. And then after that, because you're mixing between 2 different scenes, you also have this little final mixer, which takes the 2, takes scene A and takes scene B and does a cross dissolve smoothly and make sure that other things don't cook. So what I want to do now is, let me see. Let's just add some movies to this so it's a little easier to see things happening. So I'm going to go inside here and I'm going to drop a movie in, media, and I'll just grab this train video. And I'll just show you a few things here about how this works. And maybe I'll do another video here. And I'll do okay. And in fact, what I'll do is I'll pipe this into the text so I can see what scene it is. And then take that down, background alpha. Okay. I'll actually do that with this one too. Kill the alpha. Okay, so we can just see the scene number. All right. Now, the point of this is, if you're looking at all these, they'll cook, right? And right now, this one is cooking because it's being used. But the other scenes aren't cooking. All right. So as soon as I go to, let's go to scene 4 or scene 4. Now, scene 4 should be cooking. Okay, it is cooking. I don't know why it wasn't updating there, but it's cooking. But now my original movie isn't cooking. So what it's doing is, if you go inside here, The original movie, it would be scene gate here, it's totally shut off because it's switched to the other, it's switched to 0. So it's switched to this thing here. So if I turn off this view, it's not cooking because it's looking at this. Now, if I go and change it back to scene 1, it'll fade into that and start pulling it. So because it's pulling it down, it's only cooking when it's required. It's not cooking all the time. Now, the other nice thing about the way, so let me just change to maybe, well, we'll take a look at this now. I'll just maximize this. These scenes also have a template. So this template has been set up with an initialize and a pulse. So when the scene starts, you can have initialize and or you can have start clicked. And when you're finished with the scene, you can click init. You also have a play button. So let's see. When I am selected, this one here is playing right now, so play is on, right? But if I go to this one here, which is not being played, if I go and select that scene, play turns on there. So inside, you can use that to build things. Like you can use that to turn on your flex renderer, or you can use that to turn on your simulation. These init and starts are also used for stuff like that. So we could, for example, in here, we have a timer chop, right? And this timer chop is set up so that initialize happens when the init is fired, and start happens when the start is fired. And what's the active? Also play. So the other thing we could do is maybe, look here, there's a length. So we could take this length and copy it, go inside, and on the timer, let's bind that. Okay, so now we have, when we start this scene, the timer is going to start and it's going to run for 5 seconds. So you can do whatever you want with that. You can run a little timeline that is 5 seconds or make it 10 minutes, whatever you want. Then you can also use the timer chop to run a script that says, when I'm done, call another scene or go to another place or shut down this part of the engine. So you have all these basic triggers at your disposal. So what you can do is create the scene component the way you need it for your system. It doesn't have to be just these custom parameters. Create all of the custom parameters you need in your system and put them at the top of each scene. And then everyone that's building, if you're working in a team or even just yourself, whatever, every scene that you build has access to the same things. And that way, it's very easy to connect your UI to it. It's very easy for the show to control it. And everything is modular and reusable. All right. So here we also have fade in and out. You can override fade in and out times, and the show knows about those fade in and out times and will look for them and override them if they're set. What else can I talk about here for the scenes? So in this case, everything must go in to out 1. Out 1 is the thing that show is grabbing. If we go and look in here, the select is grabbing out 1. So as long as you have an out 1, your data is going to get output into the show system. It can't be renamed unless you reevaluate it. So you might, if you're working with multiple people, you might come up with a naming convention or something like this saying, don't touch the orange nodes because those are named for the show system. So leave those, and those are your final outputs, for example. Let me just check what I want to talk about. Okay. I think earlier there was a question about what if you had like a system that needs to render in many scenes, but you don't want it to be rendering all the time when it's not used. And that can also be used here. So what if there's a shared resource like a particle system that scenes 2 and 3 use, but 4 and 0 don't. So they don't have to be scenes, but they can run out here. So let's grab, I think I included some render scenes here. And SceneChanger, do I have a render scene? Yeah, a render scene here. Okay, this is a really simple render scene, right? Geo1, it's just a spinning torus, all right? But notice that when we're not looking at it, it's not cooking, so that's optimized in a good way. So what we could do is we could say in scene 2 and 3, we're going to select, and this is going to be // and at 1. Did I get it? Yep. And I'm going to put this over. Okay, and then I'll do the same. And scene 3. Okay. So what we have here now is this is not cooking. This renderer is not cooking. But as soon as one of these scenes is requesting the information by the show, so if we switch to scene 4, for example, scene 4 will start cooking. And because it's asking for information from the render scene is now cooking. But when we go back to scene black, which isn't requesting that render system, scene 4 stops cooking, render system stops cooking, and we have it optimized only that what we need is cooking. All right, so this could be a heavy thing like a particles or a simulation or geometry scene that's only used in some scenes. All right. Another thing is you might at this point here in this part of the show, you might be thinking about UI, and UI can be totally separate from the show. So over here in this component here, we have a simple UI, just this little radio button thing, which is just a scene selector. All right, and all it's doing is it has a number that comes out based on 0, 1, 2, 3, and this script here, it gets the name from the scene index. It gets the name, and then it says, please change the scene to that scene name using that extension that I showed you. So what's nice about this is the UI is totally separate from your show system in this design. So if I delete the UI, okay. If I delete the UI here, the whole show still works. It's not like it's tied in together. I happen to use it as a viewer right here, which is what we're looking at, which is a mistake there. I could have been looking at this final out here. But the point is you could swap out the entire UI and not have to rebuild anything in your show system because you're using those extension calls into the system. You're not tying the two together. So now this is looks pretty simple and it doesn't do much. It's just a video switcher basically. But let's look at how you might add audio, because these movies have audio, and this is basically the idea for this is it's a foundation that you can build other things on. If you want to start switching audio, use the same techniques and you have an optimized cooking system. If you want to start switching DMX looks for each scene, the same switching system can optimize your DMX. So let's go into scene 1 here, and what we're going to do is we want to get the audio out of this movie. So I'm going to say audio movie and like that. Now, remember we used out 1 for the video. We're going to make out 2 These are going to be our official outputs, and out 2 will be the audio output. All right. Now, if you're making a template like this, you have to have the outputs in every scene. You can't have, for some scene there's an output and from other scenes there's not, because then when the show switches to it, it has nothing to grab and you're going to get errors or you're going to get rude behavior. So even in a case where you have the black, this is a black screen, and you don't want audio, you still have to provide out 2. You still have to give it the channels. So I'll just give it an audio file in, and I'll turn off the volume and not have it play, and I'll give it the out 2. All right. You need to have that so that when we switch to it, it doesn't freak out. Now let's do the, whoops. I'll do the same thing here. Copy this, and for this one, we'll just do a nice audio file. So I'll press play and I'll bring up the volume. But we'll grab something. I included a bunch of example song assets. So it's in SceneChanger. No. Media. Music. Sure. This one. Okay. And this one, we'll use the audio movie in again because it has that. Okay. And an out. Okay, so we have all of our scenes have audio now. That's cool. We can go into the show, and what we need to do is go into the master. This is the scene gate master, which is being replicated for all of our scenes, and we have to build a little. Switcher basically. So in the select chop, I'm going to use a select chop here to grab the audio, and I'm going to be cheater, and I'm going to grab this expression from the top because I want to go to the same place. I just want to get the out 2 instead of the out 1. So in the chop field, paste that. Oh, I screwed up. I need to put it into expression mode first and paste. And then we want to grab out 2, not out 1. Okay, there we go. And what I'll do here is I'll add a math chop. All right. Now here is the fade in and out. So you'll see how this fades in and out. So I want to use this output just like it is for the switch. I want to multiply these channels here. So I'm going to do it like this for the chop. I'm going to bring this up here. And I'm going to do it like this. And I'm going to say multiply. And from here, we need an out as well. So it needs to go out. Okay. So now we can go to the replicator and replicate them all so they all have that audio. And in the scene select now, we gotta make a little mixer. So we need basically 2 select chops into a math and then an out. So let's go select A, B, and then a math chop. The math chop is just going to add them here. Add, and then an out. And I can be cheat a little bit here again and just go like this and grab this first one here. Change it to out 2. You know, if you were designing it, maybe you'd have video out and audio out to keep them clear, but I'm just doing this quickly. Out 1 and out 2 could get confusing for people that are working on this at a different date or later when you come back in 3 months. after not seeing it for a while. So naming is always good. So we have a little mixer there, and this is just adding them. And I'm going to put another out here, final out, to get, because we don't really want to come inside the show all the time. We want to have our final output here that we use for our projector, and we want to have our final audio out here, audio device out, which we use for going out to the speakers. So let's see what happens if I bring up this one. Okay. So this one's cooking right now. Now, I did find that there's one thing with the audio chop. Because I don't have a switch in here, I'm using just a math. It's always going to cook 2. The audio is going to cook the one that was last used, so the black one is cooking, but it's a very small cook time because it's not really being used that much. It's just that audio file is cooking. You could optimize this network by including a switch that breaks it entirely, but I don't have the time to get into that. But basically, these other ones aren't cooking, just this one. Now if I fade to another one, like the train, I don't know if you can hear that, it's a bit quieter, but now this last one is cooking, but the black one is no longer cooking. And if I go inside here, all of this is cooking. The other ones still aren't cooking. Okay. So pretty easy to add that. Now, what if we wanted to build a system where you had separate control over your audio and your video, right? Like right now, this is sort of a video player with music that is associated with that video, but what if you wanted a complete audio player system? So we can use the same idea and sort of duplicate this to make an audio player. So I'm gonna do that now. I'll just show you how you might, and you could use this again if you wanted like a DMX mixer. We'll use the same process, but we'll build it for a different output. All right. So let's grab a container component here. I'm gonna call this one, this is like our scene library. I'm gonna call it audio files, lowercase a. And let me think here. Inside audio files, I'm going to go to the SceneChanger folder I gave you, and there is an audio file 0. That is going to be my template for audio files. All right. Now, if we look at this, it's just an audio file and an out. But because it's a different system, notice that the scene settings are a little different. Instead of having all the stuff for the init and the length, in here I just included the file name, an active flag, and a fade in and out time. So you can make these different for every system you build. Maybe for DMX it would have a master color match, or maybe it would have like a video and an audio file name, so you could fill in both of them from the top level. That would be pretty nice. So in this case, it's going to make 5 of them or 4 of them. All right, and fill in all these audio files I got here. Just as a side note, the color here down here is set up with expressions. So based on the digits of the audio file 0, 1, or 2, based on that number, it's going to pick different colors. So just kind of a neat little expression that gives you an identifier color automatically. And there's 5 there. So if you want to see what that is, it's a HSV to RGB color sys. It's not too hard, but check it out on your own time. Okay, so there we have our audio file library. And let me just say copy. Okay, let's just copy and paste this thing, and we'll call it audio player. All right, that's good. Now, if we go into audio player, before changing anything, we have to change the settings here, and we have to say where it's going to look for the scenes, and it's going to look for the scenes in audio files instead. So here we go. And why is that connected? What's this doing here? Audio player scene gate. Okay. Let me just see what that. Oh, I see. It hasn't been updated yet. Okay. So let's go in here. We don't really need the video stuff because this is just going to be an audio player. All right. And then here, this should update because it's using a parent shortcut. Yeah, this will be fine. So let's replicate all of those. We got rid of, it just has the chop output. Oh, I know what we have to do. We have to change this select because the select is looking for out2 in the old system, and in the new system is called out1, right? So fix that, out1. And recreate. Okay. In the scene select, we don't need this. And don't need that. Okay, and here I can put in another audio device out. Now, if you really wanted to get technical, I would probably put one audio device out and have a little mixer. You could have a little mixer control with 2 levels, one for your show audio and one for your audio player audio. So you could have like background tracks with video track or whatever. And you have your own 2 slider controls for that. But just to make it quick for time, we'll do it like this. So I'm just going to kill the audio here, and let's see what happens if we can fire an audio scene here. Okay, it found them all there. And is it cooking? It's cooking. Where is it not? We're grabbing it. Let's just find out. Oh, audio, the first one is muted, remember? So that was not a good one to try. Let's try number 2. Did I turn any of these on? Yes. Which track is this? 1 second. Q active. Oh, interesting. Q, 1 parent scene active. Ah, the active isn't firing. Okay. Right. Okay. Okay, so now we have audio coming out of there. I forgot about that part. So let's go to another one. 4. The other ones aren't cooking. It's just that one. So if you had a problem following me there, I also included the one in here. It's called audioplayer.tox. So you could drag and drop that one in like that, and just get off and running to the like that. So I included it there. So in this case, oh yeah, this one is a bit different actually. This audio player was a bit different. It had just a scene instead of the fire scene. So there's slight variation I made in this, but it does the same thing. It's just selecting the scene that you are requesting. So now you can have audio over your video, your train video, or whatever you want, two systems. And you can see how you'd also build this out. What I could do is go into the UI here, and I could make a second setup like this. All right. And here in the values page of this, I don't want to go into scene index. I want to go into audio player. Audio player. Whoops. Audio player 1. Whoops. I'll just fix that. Okay. Oh, what's it complaining about? Okay, let me just check what's called here. Scene index. That should work. Show up. Oh, it's working now. I don't know why it's giving an error. It's a fake error. Yeah, maybe if I there, it's a fake error, just throwing me off. Okay, and then here in the script, you'd want to say op audio player instead of show. Okay, so that should do it. And if I try opening one of these and changing it, I got an error. Because I didn't change this audio player as well. Okay, and I have my audio mixing and fading. So I could, well, let's just take this one and be really simple about it and just move it up. Okay, so now I have my little controls here where I can switch between scenes and audio or whatever like that. So you can see, you can build multi-track systems, or you can build, you know, just a single system that is just scene-based. If you wanted to, one thing you might want to do is have it like at the end of each scene, change to the next one. So in that case, what I'd recommend is, like we were talking about in the show folder in the scene lib here, these timer chops, when they get to the finish, when they're done, you can run a script in the on done, and in the on done you could call an extension in here that says next scene. I would just like go to the next one and next one until it finished the scene index. So that would be one way of approaching that, and you can make just an organized playlist. Another thing you can do is you could send these from a different application, like through OSC. So I did that earlier, so if I just close this one, I'll save it just in case I want to come back to it. Save as TDSW. Close it. And what I'm going to do here is use that launch show from before. And in this case, I have two different ones opening here. Now, did it connect properly this time? Yes, it did. It must have been the OSC port was taken up last time. So I have a separate process here running, and this one here in the background is the SceneChanger running in perform mode. It automatically loads in perform mode. And I have the audio selector and a DMX selector, and I can just basically run this matrix and select when any audio or video combination that I want. Now, you notice there it did a little hiccup. So what I would do if I was building a system like this is on start, I would do that preload or that force cook of all your assets, so that the first time a scene is fired, it's already loaded into memory and it doesn't have that hiccup. So you can refer to the first section when we did the preloading and the op cooking to learn how to get that script. So if I just show you how I did this, if we go into this perform, this control panel. Oh, I didn't mean to do that. I hate it when Windows does that. Okay, if I go into this control panel, here it is. Oh, I know why. I have my perform mode to be always on top, so my stuff is going behind it. So I have to escape this first. Okay, now I can get to my control panel. The way I did it was very simple. I just went inside and I made that little UI that we had with the radio buttons, and then just to an OSC out. It's not technical at all. And then here, I'm getting the data from the renderer or the show system back on an OSC in. And I'm displaying that in this little window, just so I can see the performance of the show while it's running. You could even get fancy and have a little preview monitor of your current screen and everything. I didn't do that, but it wouldn't be that hard. You can imagine how to do that. And in here, to make it output, or sorry, get control from this controller, I just went into the UI and I got an OSC in instead of these button panels. And I use this constant to make sure that if it loads up with no channels, I still have channels going through the system and there's no errors, because OSC, until it connects, there will be no channels there. And here is where the stats, I output the stats on the OSC out to return the stats back over to the control panel. So really simple network, nothing fancy here, but I can now run this on separate GPUs or separate processes, separate monitors, stuff like that. So I know this was sort of a fast crash course on this, but it's quite an interesting approach for building bigger networks. And by doing it like this, where you're just selecting out the parts that you want when you want them using select operators, you're keeping everything optimized for cooking. None of this stuff is cooking no matter how many scenes you have. So think about that next time you're building a system, and try to use some of these techniques to optimize your system, so only what you're seeing or only the data that you're viewing is actually cooking. And of course, when you're looking in the networks here, it's hard to tell, so sometimes you need to turn off all your operators like this to see what's really cooking, or all your viewers, or you can use the probe as well. So if I was to, for example, bring in probe here, I think probe will work in perform mode, I think. I'll turn off that always on top thing. Okay. Huh. No, perform mode, of course it closes because, of course it closes. Yeah. Because perform mode is only one window, so that's, you can't do that, never mind. Okay, that's, I guess, all I had to show about with this. Was there anything else I put in that folder? No, the multi-track, perform, and yeah, that's about it. So, but lots of things to try there and look into. I included in the Connect version a few different steps along the way. The one without any part is the original file, and the part 4 is the finished optimized file. So if you didn't follow along quickly enough, you can jump back in and check out how we optimized from there to there and doubled or tripled the speed. And in the cooking optimizations file, all the stuff I talked about is in there. And if you have questions about that, of course, feel free to contact me anytime and ask me about it. I'm always willing to help out, explain myself better when we have more time. So I think that's all I have to show for today, and timing is pretty good. But I'd be happy to answer questions as they come in. So if you have any, let me know. Yes, I'll send my email in the chat. It is ben@derivative.ca. And you can also reach me on Twitter at vrvoigt. And let me stop this humming audio. And yeah, please feel free to contact me anytime. I'd like to hear from you and what you're doing. And I also want to get back to Chris about his question about streaming to other software. So I'll answer that after close. Well, I can answer it now, actually. Why not? So the question was to stream out top to other software, which is the optimal way. I've tried Siphon and also thought of NDI and also video capture. So there's a lot of different things to consider. If it's on the same machine, you can use Siphon because it's memory sharing. But if it's on different machines, you can't because you can't share graphics memory across different machines, obviously. So NDI will work in both cases. You can do NDI on the same machine, which is quite fast because it doesn't have to go at the network. And you can also send NDI out to another system. NDI does have the downside of some compression, though. It does compress the image to make it possible to send over the internet, so, or not internet, but over the LAN. So you have to consider that, and if the quality is good enough for you. It also has, you might not be able to get certain resolutions out of it, like 8K. You can do 4K 60 with the right hardware, but it has limitations to how much you can send down the network cable. So the best for multi-machines, like the best quality, also with the highest price tag, would be SDI or some other high throughput direct connection, like broadcast quality stuff, because there's basically no compression, and the latency is very reliable. And once you get it set up, you might have 3 frames of latency or 4 frames, depending on the hardware you choose and if you have GPU direct and all that stuff enabled. But SDI will give you the best quality and definitely the most reliable. NDI is great and it's free, but if you have network problems that day, you might have your signal degrading, or you might have your signal not connecting or something. So a little bit more work, or a little bit more things to monitor. And you said for a large project, 2 machines would be better, one for TD, one for mapping. Sure. And then for a smaller scale, maybe 1 machine that can handle both. Yeah. So on the 1 machine, you have more options. The other thing you might try is the touch out, touch in top. They, let me show it here, touch out and touch in. I guess it's sort of like, we've had these for years, way before NDI, but it's basically Touch's version of it. And you can send it uncompressed or HAPQ. So uncompressed is very heavy, but if you want to keep good quality and you have a resolution that can handle it, you could try that. Just another option, basically. Most people use NDI now, but this is one option as well. So, and what else? Other question? Email. I think I got that. Yeah. Okay. Sorry for going so fast. I definitely had too much content today, and I tried to stay on time because that's what I wanted to do. But I'll try to explain some of the things that I skipped over in maybe a blog article in the future or some documentation, because there's a few things that I didn't have time to touch on today. And I hope you all enjoyed this rather technical talk, but I hope everyone came away and learned something. And cheers to TDSW for inviting me, and also for just helping the community like continue learning. Every 2 weeks about there's a TDSW event, and we're very grateful for your efforts of extending the community. So thank you guys.